In this video, we'll see how energy distribution into various levels gives rise to an entropy. Anything that can be discretized results in a W and hence in an entropy. Energy can be discretized into separate energy levels. This is also called quantization of energy. We have seen that the atoms vibrate and the vibration increases with temperature. Let's say a material contains 4 numbers of atoms and 5 quanta of energy. Those 5 quanta can exist, for example, in this distribution. One set of arcs indicate one quantum of energy. The second atom has 2 quanta. The third and fourth atoms have 1 quantum of energy each. Let's say this is a hot material, and a similar material in cold condition will have less quanta of energy. Here, for example, there is only 1 quantum of energy. While calculating the number of ways in which the energy quanta can be distributed among the atoms, probabilities come into picture, the W. Let's see how to calculate it for the cold material. 4 atoms, 1 quantum of energy. It can be associated with any one of 4 atoms. Therefore, W is 4. In the hot material, we have 4 atoms and 5 quanta. To calculate the number of microstates for this kind of a problem, the ideal way is to use what is called the stars and bars formulation in combinatorics. According to it, the entity to be distributed, the number of energy quanta, is represented as K, and the entity to which it will be associated, the number of atoms, is represented as N. With this formula, the W turns out to be 56. If hot and cold materials are joined inside an adiabatic container, what will happen? Intuitively, we can say that heat flows from hot part to the cold part, and eventually an equilibrium state, a warm state, will be reached. Here, since there is no material or heat exchange with the outside, we can treat one material as the surrounding and the other as the system. Let's say the hot one is surrounding and the cold one is the system. We can calculate the entropy change for both of them, see whether the total entropy increases or not. If it increases, only then we can say this heat flow can happen. In the initial state, there were 5 plus 1, 6 quanta of energy. So what happens when they join? The energy becomes equal. So in the final state, we have 3 quanta in both the parts. The W for 3 quanta among 4 atoms turns out to be 20. That is the final W value. Therefore, we can take the formula for entropy and calculate the entropy change. The K here is Boltzmann constant. It is equal to minus 1K for the hot part and plus 1.7K for the cold part. Therefore, the total entropy change is 0.7K, which is a positive quantity. Therefore, the total entropy of the system and surrounding increases from the initial state to final state. Therefore, this process is allowed in nature. See you in the next video.